Okay, we're going to go back over this timing deal again. So we're going to start over because he's kind of confused on how to do things here. Okay, is it on? Okay, we got our smart meter. So basically, one wire goes to ground and one wire goes to these two here to figure out which one's hot. We already know it works, but this, let's say we didn't know.
Okay.
Where's the meter? Okay, so we're on auto mode. So touch one of your bolts because you want to screw up your polish.
It's ground, right?
I would hope so.
Wire.
You hook it to that. We got 0.76, and we're on ohm. See how it's got an ohm thing over there?
Uh-huh.
It's got M and ohm, so it's on something that's not voltage. So that's not voltage. So that's not 12 volts. Okay, now touch the other wire up there, which is the other wire is on that coil.
This red one?
No, the other one.
Here?
Mm-hmm. Says there's a circuit. So we got a circuit going to ground. Okay, now I turn the ignition switch on. 12.25 volts. It was 12.7, but it's dropping on the battery. We're losing 3.
Lights on.
We're losing 0.3 volts though, which is not good. Okay, we're 12.2 volts. Now touch your positive up there to the far lead. Quit jerking so much because I can't keep up with you. Okay. See, we're 12.51.
Yep.
So we're losing 0.3 volts, which is not good. So that means you got a lot of resistance going somewhere in the system.
Okay.
We're going through the ignition circuit, circuit breakers, on-off switches up there, and working our way down to this power here, which comes off that switch up there. And that switch is powered by this switch right here. There's probably some connectors going between the two, I would imagine. Quick disconnect, I would think, up to the handlebars harness somewhere.
Yeah.
Or it's hardwired
They
down.
come down and there's a plug here.
Yeah, there's a plug up in there.
Yeah.
And then I'm assuming there's a circuit breaker somewhere under here that all this power comes through here. And it might go up back, come down, and do that kind of crap too. But going through all of those different leads and connectors, we're losing 0.3 volts. So basically your bike is seeing a dead battery. Because 12.3 volts is 50% power. Now when the alternator's running, it might go up. Maybe your full 12 volts. A fully charged battery is going to be 12.7 to 12.8, right in that area. An overcharged one right off a charger, you'll see 12.9 to even 13 sometimes, but these about 12.9. And will dissipate after a few minutes, and once it cools off, it'll drop down to whatever voltage is in it. So right off the bat, that's some of your loss of ignition. Whether that's affecting the module over here on the other side because it has low voltage to it, because this is not seeing full 12 volts, it's seeing 12.3.
Right.
Because that wire, that one that's hanging way down low, I assume goes to this one, because it's the white wire that's not hot. So I'm assuming it's going through this, because something was powering this thing. Because you know, we jumped it together, we had power. So somewhere there's a loss in all this harness. Now, it's not here because that wire is different. Or is it going to, let me see, what was that wire hooked to? No, we were hooking directly to ground. We weren't hooking it to this.
Right.
So we're not having this powered up, saying this is a voltage drop. The voltage drop is between ground and the positive wire going to your frame. So we have voltage drop. So that's not good. You don't want to see that much, that's a lot. But anyway, so if you have a sensitive ignition system, that's going to kill some power. Okay, we measure the two coils over here. So we had 12.9, or not 12, 2.9 ohms on this one, and we had 2.9 on this one. This is a dual fire, because it's got only 2 leads. It fires both coils at once. This is a single coil with 2 outputs. This is actually 2 coils down here, so it's split in half. You got the hot wire in the center, and you got your front back or back front. These are 2 here. There's actually 2 separate coils right next to each other inside of here. And these are 3 ohm. Both of these are 2.9 when you measure them. So you got the same output. These are both good coils. They're both dyna coils. And they're both got the same power to them. So we're going to a single fire ignition. We have to have two separate coils to make it work, because each plug will be independently fired. Now the problem he has is how to figure out timing without having the push rod covers off. And this is not a two-stroke motor, so it does not fire every time it comes up. It comes up, it could be on the overlap stroke where both valves are open, which you don't want to be firing on, or it could be on the compression stroke where it is firing. And whatever cylinder this one is on, this one's on the opposite, and vice versa. But they're not exactly 360 apart because you have a 45-degree angle in here. So one side's ahead 45, the other one, it's 22.5 ahead, and the other one's 22.5 behind. So it's 45 degrees difference on your number. So it's a 275/40 split, I think, is the number. So one cylinder has more dead time before it fires than the other. And that's why the carburation doesn't work on these bikes equally, because it's not equal suck. If it's on a vertical twin or a more even, or one that fires exactly 360 apart, then the pulsing through the carburetor will be a lot more equal. Your fuel curve will be more equal on both cylinders. But being that they're oddball, they don't fire anywhere near the same. That's why your carburation varies a lot on these things. And the ignition is the same thing, because on this one here you got a wasted spark with a dual fire, and so you're firing the spark plug when both cylinders are open, when both valves are open. And we are getting a backfire out the tailpipe every now and then. So by going to single fire, hopefully we eliminate that problem. If it isn't that problem, there's a problem with a circuit breaker or ignition or a switch up there is not contacting correctly, and it's breaking contact and causing a misfire. And that could also be why there's a 0.3 volt drop in voltage. We have a bad connection someplace. So if the single fire doesn't fix the problem of the backfiring, we know there's a problem in the electrical circuit someplace. We have a lot of resistance. Okay. So that just tells us there might be a problem somewhere else. All right, so we get all that down. Now basically, when both valves are open, there's no compression. Because you can't have compression here if you got one or two big holes going on. In this case, two big holes, because both valves will be open at the same time. Okay. So you'll have no compression. You'll have no airflow either. You won't feel it. If the motor was turning over fast, you would feel a pulse and of air going through, but there's no pressure behind it. Right. You know, a couple pounds, nothing. Now, as long as both push rods are functioning in the motor, you're going to have one dead cylinder and one compression cylinder. Okay. So all you do is turn the motor over until you feel compression. And the way we do that is we put it in high gear, which I was in. You spin the motor around and you feel it. So right now, you push backwards on a wheel like this, then you can bump it like this or just push hard. Hold your finger up here and see what happens.
Yeah, sucking.
It's sucking. Why is it sucking?
Because it's going down.
Because it's going down. And you never want to reverse, you want to keep going full circuit. So if you put your finger on this one, you'll feel compression when you go around. I can hear the air leaking. I hear it? Yeah. That's compression. Stop. So, you need a Phillips screwdriver. Now, was it still blowing, or did it start to suck on you?
No, it's starting to suck. I can't tell.
Okay, you're either right near it. See now it's going down. You went past it. Yeah. So next time around on this one, which is the next turn around, we're going to be on this one now. Stop turning it before you go too far. So once you start getting compression, it's time to slow down. He's fighting a lot of valve spring tension.
Okay, we got compression.
Okay, so next, quit moving it. You put that in there. You want to keep it up as vertical as you can so it doesn't bend over. Okay, drop it all the way down the hole. Is it all the way down the hole? Okay. Okay, stop there. See how you're fighting at the spring rate? Okay, stop.
We should be real close here then, right?
I think the mark is over there. Where's the Phillips right here? Not yet. Okay, hold on. Now the problem with this bike has a cam in it. It's got heavy valve springs in it. So the motor does not want to stay at top dead center on the front cylinder. It wants to be back here. So every time you move the wheel forward, it goes right back from spring tension. So now we're going to go on the other side and put a little drag on it. Okay. So the way we're going to put drag on it is by having the rear brake on a little bit. So we have the strap over here. So it starts making pressure there. Put light pressure, not too much because we want to be able to make the brake work. We want enough that the wheel will stay put. So bring that down a little bit, kind of feel it as you go. Push the pedal down until you feel the sweet spot. Okay, don't push real heavy, but just light. Okay, we got a little bit of pressure on it. Now let's see if we can move this at all. Yeah, I can move it a little, very little, but it moved. Now it's going to be hard to work because you're by yourself here. So, first thing I do is check for your TD. So we know we're on the compression stroke now. We know we're really close. So what you're going to have to do is push the wheel to the back. And what I do is I take a flat blade screwdriver.
There she
and I
was.
put it in
I
here.
went past. You see her?
I put the screwdriver in there until you find the slot. Usually you're going to come up on it. So here. It's going down.
Yeah, there's a lot of backlash, huh?
Yeah,
Did I
the
miss it?
screwdriver hasn't moved yet. Okay, it just went down. Okay, now go back the other way. You got to bump it, but it's going to be hard to do because I don't want to bump. So hold the screwdriver at an angle. You want to stop the flywheel movement by being at an angle. So put an angle on it. You know, you might have to take some of the brake off. Is it moving at all, or you want to take the brake off? Now, once you get to the slot, you can use the screwdriver to move it.
There she is.
Okay.
Man, we hit almost dead center there.
Okay, there's his slot. He's actually slightly further forward than it needs to be. That looks dead center there, pretty close. Maybe just a tick more. Right there looks dead center. Okay, so now we got jumper wire this together so we get some power. So grab your jumper lead. Says here plus 12. And this is a power to the bike. And just make sure it doesn't go back on the ground. Okay, so it doesn't hurt to put a little rag or something around that so it doesn't go to ground. Don't cover up your hole, we need to see that. Just wrap it. You put that around like that, wrap it there. That's fine. We got access to our hole. Okay, now let's go on the other side of the bike. Now I went ahead and marked this before when you left, so
Right,
it's just
okay.
marked. So this is where actually the timing was before. Okay, now let's work on this side. Okay, first thing I'm gonna do is break this thing free. And then we need my small screwdriver, which is, I put back over here, I'm guessing. Small screwdriver. You need a small screwdriver like this, not super small, but small. Okay, just loosen them all the way up so you can move it. Okay, so you want to just make this so you can move it. See how you can move it back and forth? See how it moves front to back? Pretty easy. Now why is it stopping there? We bottomed out on our slot right there, look at that. See, it won't go any more than that, which is almost where we're at. We're bottomed out in the slot. The slots are so narrow.
Yeah.
We're pretty much using up all of it to do it. Okay, so when you put this back here a little bit, here you hold the camera. You want to come in here and put tension on this. Just light tension, not much, just enough to hold the plate. Okay, now, as I put this in here and rotate it, see I moved it even that way, but the plate will actually move because there's clearance in the plate in here a little bit, so it's not a direct movement. So you want to get it where you move. See how it's moving up? See, it's not just going this way, it's going up also.
Yeah.
Okay, so that's our problem. And we don't have enough tension on that, screw's loose, so we put a little tension on it again. As long as you do it the same way each time with tension, you know where you're at. See how it moves it? Okay, so we'll go ahead and move this back quite a bit right now. So I'm going to go ahead and loosen this up a little bit. Move it over there. Put a little tension on there.
And moving that way is retarding it, right?
That's retarding it. The cam is moving counterclockwise, so it's going this way.
So we move it retarded, put a little tension so that we know
So if you move it this way, you're running away from the crank, so you're retarding. If you go forward into the crank, you hit sooner, you're advancing. You always want to go from retard to on. So right now we can move it that far. We know that because it's already there, but we might not have known that before. Okay, now we got our module timing light right here. So we have to turn the ignition switch on. Okay, we're not triggering that yet, I don't know why not. Maybe I gotta turn it on and off once to make it do it. We're not on 102, I'm not sure. Should come on at some point. Okay, we have no ignition or something. We're still connected?
Power here. White wire jumped over to.
Okay, I got it working there. We had to move it back and forth a couple times to let it know the motor's turning. See? Okay, we got it working now. Okay, so I'm going to back it up a little bit. I'm going to put tension on these screws. The light's on. Now when the light goes off, this is where you time it. See, you rotate, see how it went off? But see, I just was turning it quick, so I might be past it right now.
Right.
So you want to go back on the thing a little bit. Screwdriver's a little hard to get in there. Okay, I want to make sure I go well past it. These screws loosen up on you, so you got to keep the tension
A
on
little
them.
snug, right?
Okay, now we come back on it. The light's on again, see? Now you rotate this really slowly till the light just goes off. Right there, it went off. And then once it goes off, go ahead and tighten your screws down. The line's identical, same spot probably.
Yep.
That's how close it repeats, pretty close.
Real close.
Now we go on the other side. Put the ignition off. We look in here and make sure that did not move. We're dead center.
Dead center.
Now, if we weren't fighting this so bad, the next test is to back this up a little bit, which is what I'm going to do. But I'm going to use a screwdriver to do it. Use my screwdriver.
Okay.
I want to get it past. Same deal. You want to go too far back. Okay, so I'm way back there.
Right.
Okay, now you go back on. Let's see if the circuit is on right now. It is not on because I got to trigger it. So I got to turn this back and forward until I trigger it. The light on now?
Nope.
On?
Nope.
Nothing?
No light.
Should be triggering. Take the brake off.
Okay, lights on.
I couldn't go back far enough to do it.
You want light pressure here?
Okay, no, I'm good.
Okay.
I'm over here. Okay, so I got the screwdriver in a slot right now. And the light should be on right now. Okay, now if we can put the light up here, I can see it.
Yep.
Can we get up high enough to see it or not?
Yeah, I think you can.
Just get up there where you can see it, or put it up top of the bike or someplace. That's fine. Right there's good.
No.
Okay, now come around over here.
Here, I can hold it. Yep, I can hold it. I don't know if we
Okay,
can.
so I'm going to rotate the crank with my screwdriver until that light goes out. Now I got to push the screwdriver in because it wants to come out the way I'm putting pressure on this side of the thread. I'm going real slow because there's no brake on it right now. Should be off already. Right there, it went off. Okay, there's where it went off. See, I'm just a tick retarded. Let me double check. We'll back up. So you had to go back that far
For it to.
for the light to come
Right.
back on. And we're going to do it again. Right there, it went
there.
off. And
Lights
we are
off.
slightly 1 degree retarded, maybe. Because it's not quite centered hole.
Right.
And that's because that was our error, 1 degree.
All right.
So we can try that, run it like that, and if we don't like it, we can always cheat and have to move the plate a little bit more.
Okay.
Even though this mark looks like it's the same spot, is it exactly the same spot, or is it a little
It
bit?
may be slightly off. It looks like.
It's retarded.
I mean,
got it.
you know, just a touch.
Okay, so we know it's retarded. I can see it. It's not 100% where it was. Okay, look out. we're retarded 1 degree, and we can see it's retarded. It's not 100% in the same spot. Do my screwdriver here. Okay, now I'm going to move this. Attempt to move it. Does that look better?
Yeah, maybe
Up a little
more, right?
Yeah, just a tick more.
That might be hard to see on this camera angle.
It's really hard.
Like that right there looks pretty good.
It's really hard to move the plate right now. I got a lot of tension on it. So. Okay, it looks dead nuts now. Okay, now we can go back and double check this. Over here. See the hole? See the slots right in the back of the hole right now?
Yep. So you can see that.
Okay. So I'm just doing my screwdriver, and I'm going to go forward until the light goes off again, until it just goes off. Right there. Now this should be pretty much dead center.
We look a touch advanced here to me.
Okay, go back and check it again, and we'll. Right there, it went off.
We look a slight bit advanced.
No, it's in the center. If I had a screwdriver out there, it'd probably look better, but it's back slightly from where it was. It's pretty centered. See how fat the area is there? My screwdriver's blocking it, but it's slightly more fat in the front than the back, but it's really, really close. The amount that we were too far forward before, now that's how much we are in the back,
Right.
and that's where I had it before.
Right.
You know, just a little bit more advanced, and that's where we're at. So I can't see the motor's not being held there. Now if you put the brake on and play with the wheel a little bit, we can probably duplicate to do where we want it to be.
Right.
So if you want to try that, you can put the brake on slightly. We can try it.
Okay.
Let's go to that. It's up to
Okay,
you.
what do you want to do?
You can see where it's at. I'm good with what it is, but you want.
I'm good where it's at too.
Okay.
Touch advanced, any of this.
It's doing the same thing. Turn ignition off. Now you're gonna have to get it. You have to retard it enough to engage the light.
Right.
So we had to back it up. Basically, half the window is what it took to advance, make the light come on and off.
Had to take it forward this way.
Well, if I'm on the back, if I'm here, I had to go all the way to the back. And that's what it took to get it to come on. Once the light starts coming on, then it does what it wants. It's repeating exactly where we're at. Within a few thou on that crank,
Right.
it's repeating.
Right.
So it's doing its job, what it's supposed to be doing. But that's how you time it. So, like I said, with a bow spring tension fighting you, this is the kind of problems you run across. And you got, if you're actually in gear on the bike, it's a little bit easier when you have the wheels on the ground because you can roll the bike back and forth a little bit.
Right.
You got the
You can
leverage to
hold
move it.
Right.
Yeah. But you have a lot of backlash in your powertrain, so you have to work around that. But what I do is I just kick the kickstand forward a little bit at a time until I get exactly where I want it with it pushing against
Right.
the backlash in the gears.
Yeah.
And once it's there, it's there. And then you go do all your timing, and if you want to do the check, same deal. You move back a couple inches on the ground, come back into it, and it'll repeat every time on the mark on the ground.
Okay.
But it's very accurate when it does it. And it doesn't matter if it's that module that's remotely on the outside or the one that's under the cone cover. It's the same thing. It reads the same pulse down the bottom.
We ran this unit because you felt like these live longer because it doesn't get the heat off
These
the motor.
not get hot like the one under the cover is. Because this motor, if you went up here and touched it after you got off the bike and run it, it burns the piss out of your fingers because it's probably 250 to 300 degrees, depending on how hot it was.
Yep.
It's at least 250. It sizzles water right off of it, and it'll burn the snot out of your hand. So you got to be careful. And with your exhaust pipe wrapping around your motor there, it ain't helping the situation any.
Some pull heat right onto it.
You get all this hot air being blown right onto from this side, and it's wrapped around that side and wrapped around it. There's no air to it, and it's hot everywhere.
Yeah.
So it runs hotter than normal. So this sensor gets hot, and it will burn these things out. I've even seen these things melt. Usually it's because of an electrical issue, though, but not from heat. But it's hot in here. It's enough to soften the stuff up. When you got it way back here, up here, there's nothing back here. It's hot. The oil tank's warm, but it's insulated behind all this stuff.
Yeah.
Now this one's a steel one. Some of these I thought were plastic, but I guess they're all steel. But so you're gonna transfer some heat here, but there is a gap between there that's thickness of your finger.
Right.
And any kind of an air gap means that heat of this is not transferring this directly. It's gonna drop a lot. Probably 70% drop in heat with just a finger clearance. So this module's not getting really any heat coming from this tank. Basically nothing. This thing might be 120 degrees maybe at most. Probably not even that. And that's not any heat at all. And if it's under here, you're gonna be 300 degrees, 250, 300.
Right.
So those modules will live a lot longer out here. The disadvantage is you gotta have that module mounted out there and all the wiring go into it and all that. On a custom bike, you don't wanna see all that crap. So on this bike here like this, where it's all buried up underneath stuff, you got a lot of crap on it, it's fine, you don't even see it. There's just more stuff going across the bike. You already got a lot of electrical going all over the place and hoses and other stuff, so it doesn't matter, it blends in. So it's more, you know, it's gonna last a lot longer up there. The only disadvantage is we have to take the module off to do any adjustments. That's the problem with these things. But yeah,
Not that big of a deal.
it's not that big of a deal because we don't do it very often. It's been what, 2.5, 3 years since you put that on there?
Yeah.
So
Yeah, it's 2 4. Yeah.
yeah,
Maybe
so
longer. When did we
it's
start
been
this
3
bike?
years. Well, now we took it back off to play with it. I can do that once a year and not worry about it.
Right.
And we did it once every 3 years. Oh well, no biggie. So now we got the advanced curve jacked up. We got this back on the timing because you were what, half thickness of the line off.
Yep.
Is what you had it advanced. So he might be 1 or 2 degrees more advanced when he was running before. Now, if you get any kind of a pinging problem or something that doesn't feel right, just go back and move the curve back from curve 1 to curve 2.
Okay.
It's just a matter of going back up in here, reading what position that is, and here's your curve. Curve 1's off, and then curve 2, you got to turn on the number 2 switch, gets turned on.
And curve 1 is the most advanced.
Most
right?
advanced. It's 35, 36 degrees of total lead. And it's in there early. It's in there by like 2,000, 2,200, probably around 2,200. Curve 2, it's going to be almost identical. I think it's 34 degrees total lead, but it's not fully advanced until like 2,500 or something like that. So it stops the detonation at lower RPM if you have a detonation problem downstairs. You know, especially if you do a lot of commuter where the motor gets really, really hot sitting all the time. You go to take off, it rattles a little bit when you take off. You definitely want to drop the curve back.
Okay.
But on this bike here, it probably won't matter, but if it doesn't like it, just put it back. And if you don't know which one it likes or doesn't like, you ride around one curve, then you flip it to the other one, go right again.
Right.
And see if it runs any different. If you don't notice any difference, leave it on the more retarded one. It's more protection if it gets really hot. But, you know, not every bike likes super high ignition time in them. Now, my race bikes, I tend to run more than 40, 45 degrees of lead in the things. I advance the piss out of them.
Okay.
You know, gets more power up there. But if you go too far, you start running 45 and 50 degrees in them, they actually slower. It slows down. You went too much. We don't ping because they're on race gas, but the motor loses power. Because you're fighting it. The piston's has to fight the compression that you're building. You know, when you fire that plug off, that cylinder now is expanding. Well, if you're still bringing your piston up, you're fighting that. That's going to cause power.
Right.
When you go over center, it's going to have a lot of peak pressure now. It's pushing like hell on the other side, but you have to get up there
Yeah,
first.
get through it. Right.
You know, it's just like those valve springs we're fighting right now. You know, when the bike's running, it's all right, but right now we're fighting it to turn the motor over. So it's like everything. There's trade-offs to everything you do. All right, so like I said, this one here we had to cheat the brake pedal a little bit to make it more easier, but that's just how it is. Some motors, they don't have that problem as much or not at all, depending on, it's just all about the cam timing, the lobe center of the cameras that install that and all that kind of stuff. So in this bike here, we're fighting a little bit. All right, well there you go. We'll go ahead and put this all back together. We'll be back.